Okay, so there are some things that physicists and engineers do a little differently, and I thought I would show you how we might draw a free body diagram. And this sort of is going off of the thing that occurred in the class the other day, where we had there was a a frame that was used on the table, you recall, and there was a string and a ball, and then another string. And then Pete took a bar and yanked that whole assembly downward. And what we saw first was this string right down here broke. And so I thought I would sort of show you how an engineer might set this problem up. So looking at this, what an engineer might say is that, well, we can simplify this diagram and look at two things. We want to look at the forces, and we want to look at the motion. And those are very different ideas for us. So forces, as Pete said, they're essentially real forces such as contact forces, and there are forces at a distance, and those are things like gravity comes in that category. Electric field and magnetic fields also are forces at a distance. And again, contact forces are the things that we've been talking about in class. There are tensile forces, they are normal forces, and I'm using this designation to indicate that they're vectors. Tensile forces and normal forces, essentially these are the contact forces that we're working with. Now motion, again, very different idea than forces. Motion is represented by the terms that we have been using in class: acceleration and velocity, both vectors. And then you can also look at displacement as well. I'll just put that there, x. Okay, so how would we set this problem up? What we would do is we would draw two diagrams to indicate these two different considerations, one for forces and another one for motion. So the force diagram is what we call the free body diagram. Free body diagram, or free body diagram. And over here we would draw a diagram to indicate the motion, and we would call this the kinematic diagram. Okay, kinematic meaning motion. Kinematic diagram, or KD. And the free body diagram looks like this. We concentrate all the force that's happening onto a point. And so in this diagram, I'm going to consider this as my system. So I'm going to look at that ball and then the two strings and then the bar pulling on that. So onto this point, I'm going to draw the forces. I use a different color here. So we have the tensile force of the top string. I'm going to call that T1. We have the tensile force of the bottom string, and these might not be to scale. I'm going to call that T2. And then we also have the force of gravity, which is expressed in the mass times the gravitational acceleration. So those are the forces that we have at work. And we don't write anything else on this free body diagram, just the forces. So we know that when Pete did the demonstration in class, he yanked on a bar here, and that caused an acceleration in the downward direction. So what an engineer would do is they would sort of recognize that by just putting on the side here that there was acceleration in the downward direction. Now what would we do in the kinematic diagram? Well, in the kinematic diagram, we would represent the motion. And the important thing in the kinematic diagram is to first of all draw a set of axes so that we know what we're talking about. Now, one set of axes that you could put on there is you can put a y-axis here. Typically, in a kinematic diagram, you would do an x and y-axis here. In this case, we don't really care about the x because we don't have any motion going on in the x direction. And I could leave my y direction pointing in the upward direction like this. This is one way to define my axes. You know, I don't think is so great because the acceleration is in the downward direction, and then we have to keep track of a negative acceleration. So, honestly, what I'm going to do is I'm going to define my axes like this. I'm going to say that this is my direction of concern, and I'm going to call that, I'm going to even call it the plus y direction. And what I'm going to say is that, as we know from Newton's laws, is that we know the sum of the forces in the y direction is equal to the mass times the acceleration in the y direction. Okay, so now that we have these two equations set up, these two relationships set up, we can begin to write the equation. So we can begin to write the equation for the sum of the forces in the y direction.